Hello and welcome to CHEMS. Did you know breweries, yes, the same ones that make your favorite craft beer, release carbon dioxide during fermentation? Well, what if I told you that CO2 can be captured, purified, and reused right inside the brewery? Last week, I had the opportunity to visit CO₂Brew, a Canadian company helping small and craft brewers turn emission into opportunity, creating a self sufficient CO₂ supply while cutting greenhouse gases. Let's hear from the CEO how they're brewing sustainability one pint at a time.
My name's Ken Swanland. I'm the CEO and co-founder of CO₂Brew. And here you can see our demo unit. This is the first installation we've done, and obviously a lot of learnings with the demo unit. And with that, now we've designed our commercial unit, which should be out within the next couple months. Yeah, so these are the fermenters. So brewing process-wise, how it works is those three vessels back there, they create the wort. So they take water and they take all the grains and stuff, they mix them all together, put them in there, cook them, and then once they've created their wort, then they transfer the wort into a fermentation vessel. You'll always know it's a fermentation vessel because it has this conical design. And the reason for it is all the stuff that's stuck post flipping it from those vessels to the fermentation vessel. It'll collect in the bottom over time. It'll drop out. And so here is where the fermentation happens. This one's fermenting right now. Yeah, there's a couple bubbles. So what we do is just connect onto this hose and pull it through. So it gets fermented here. Now, after it's fermented, which takes about a week, let's say, then they push it to a bright tank, which is these tanks here. And they have a more flat bottom. And essentially, it's like a clarifier. And so it stays in there for 2 weeks, 3 weeks, and then they can keg, do whatever they need to from that vessel afterwards. Yeah. So yeah, all the collections here. Now there's other steps that we can collect. So for example, they can't have oxygen in these, so they purge it with CO2. So we can collect the purged CO2 gas and send it through our system. And then with our new optimized design, we can get up to really, really high inlet oxygen levels and still get a per spec CO2 capture on the back end. And so that's really important. It's like how high O2 can you get up to? Because the more gas you can collect off of purges, the better. Because they go really high pressure and you're filling an entire vessel. So you're using quite a bit. Yeah. In this example, we just have two headers, two drops going to the header. That's because we only produce from one gas vessel at a time. So we don't need check valves or anything. Okay. It's just going to the one vessel. Then from there it goes in. We do have a foam trap in the back. When it's on, it sprays water. So in case you get foam over, because they get foam over sometimes in these fermentation vessels. So to get rid of that. Then after that, it goes through water stripping. So two of these are water stripping. And then the other one that we need to get rid of sulfurs and VOCs, volatile organic components. So it goes through the last one. And then it goes into the back, and then it's compressed and then sent through essentially an exchanger where the refrigeration cools it down to liquid form and then gets stored in the tank. Okay. Yeah. So all in all, it's like very similar to what you see in a lot of the oil and gas stuff. Like right. All of these things, which is what I thought it's like a VRU system shrunken down. It really was. It's just the details. When you start getting down to the details, you're like, oh, especially since it's food grade. So because this is all being consumed, you really have to watch out for anything food grade. So the materials you use, what's produced, how you're collecting, all of that stuff. You need to make sure you're at that food grade level. So, yeah. Which is the reason we ended up going with stainless steel. But in the next version, we don't want to. One, because it's heavy. These panels are ridiculously heavy. I've been taking them off a couple times. And two, it just adds cost. So then it starts becoming like, we could have optimized this in cost, but we wanted to get it out quickly. Whereas in the next revision, we need to be able to duplicate it, replicate it, and it needs to be the most cost-effective possible, but still do the job it needs to do. So really the big thing between this unit and the commercial unit was being able to optimize that cost while still getting a product out that does exactly what we needed to do.